What is this? What is this? This is Nemo, my 5 volts converter from 12 volts to 5 volts connected here. What we have here? Oh, it's a transistor again, and an LED resistors and a push button. 1947 technology, 1940s. Very Jurassic circuit. What we have here? Push the button. Oh, there's no light. Let's first turn on the power of Nemo, my 5 volts power supply. Now, we push the button, LED turn on. With its 1940s technology, push the button, LED turn on, and this is a transistor as a switch. Push the button, release, push, release the button, push the button. Seems like the same as with my old circuit, but let's check the circuit diagram here. It's not the same. The LED is in the collector side of the transistor, and I have a 5 volt supply here. So the LED in series with the resistor, current limiting resistor, then a base resistor here. We don't know the value of the two resistor, but this is my design. Transistor, push button, resistor, LED, resistor, and a voltage supply of 5 volts. We first have to, what is the purpose of this? This is a transistor as a switch, version 2. Last time the LED is in series with the supply. Now it's in the collector side of the transistor. Let us check if we can calculate the value of the resistor and if it works. So we're going to make the transistor to conduct in saturation state, making the current here to flow directly to the ground, short-circuiting the transistor or operating the transistor in saturation state. So let's find the resistor value of this diode. First, find RD using Kirchhoff's voltage law again, my favorite magician. Using the sign, we're going to have a Kirchhoff's voltage loop here. Negative BS power supply plus voltage resistor of the diode resistance, voltage drop across the diode LED, and the voltage drop across the collector emitter in saturation. See, voltage drop across the resistor in saturation collector to the emitter is 0.3, somewhere in the table. It's 0.3 with this 222A transistor. 222A transistor. So we calculated here the voltage set. Saturation is 0.3 volts from the data sheet. Supply is 5 volts. Voltage of the diode is 2 volts in data sheet of the diode LED. So we now have voltage across the resistor of the diode is voltage supply minus voltage the diode. Voltage supply minus the diode plus the voltage of the collector emitter in saturation 0.3 volts equal to 2.7 volts. We now know the voltage across the resistor of the diode. Let's find out the current flowing here. Since the current is in series, the current of diode is given in the data sheet, which is 20 milliampere in order to turn on the LED. So in series with the resistance, same current in series. So we now know that the current at the diode is equal to the current of this resistor. So current RD is equal to current of the diode is 20 milliampere. So again, my favorite magician, Ohm's law, voltage across the resistance of the diode is IR is equal to IR, resistance diode, voltage over I. We now know the voltage across the resistor here, 2.7 divided by the current, same with the current of the diode, 20 milliampere. Now we have here converting it to ampere, voltage over A is equal to resistance, converting to the left, making it 0.02 according to the mathematician, the expert in math. So our RD now is 135 ohms. We use 200 ohms. That's my available resistor, 200 ohms for the RD here. Now computing for the base resistance. Again, we're going to use the Kirchhoff's voltage loop for finding the RB, base resistance. We're going to go here and then to the ground. And push button is close. The current flows here. We're going to pass the current 20 milliampere. The current in the diode to pass here to saturate the transistor. Voltage here, Kirchhoff's voltage loop, negative Vs. Here, plus BRB, voltage across resistor base, and the voltage across transistor base emitter in saturation is in the table loop here. Base emitter voltage saturation is 0.6 volts. If IC is 150 milliampere, it's okay, we're operating here 150 milliampere because we need 25 milliampere to saturate this transistor. So we now have this one. This formula is equal to 0. So according to my magician, all voltage in a loop is equal to 0. So we got now voltage at resistor base, voltage supply minus the voltage of the transistor, base emitter, and saturation. We now know that is 0.6 volts here in the table, as I said. 0.6 volts here. Base emitter, saturation under this 150 milliampere. We are operating this under this 150 milliampere. So we have now voltage across is 4.4. 5 minus 0.6, voltage supply minus B sat 4.6. Now this is a transistor magic formula again from the expert in transistor. HFE is equal to IC over IB. HFE is 100. The HFE current gain of this transistor 2222A is in the table also, or in data sheet here. On characteristic, the DC current gain along, we are operating under here 150 milliampere. Our 25 milliampere IC is under here 150 milliampere, equivalent to 100 HFE. So we have 100 HFE here, and the relation from transistor magic formula, IB is equal to IC over HFE is equal to 20 milliampere divided by 100. Transposing it to the left, making it ampere, 0.02. Now over 100, IB now is 0.0002 ampere. Using again the magic formula, Ohm's law. B is equal to IR, my favorite magician. Voltage across the resistor, base resistor is equal to current of the resistor base and the resistor. So since we know that IRB is equal to base current, this one IRB, the current here is equal to the base current, but we know now the base current 0.0002A. We know this voltage here 4.4, and also the current. So RB is 22,000 ohms, 22 kilo ohms. So RD is 22.0 kilo ohms. I am using 22.2 kilo ohms, my available resistor. There. So we have pin out to 2A, EBC. It's a BJT NPN transistor. We have LED here, 10 millimeter green. And the forward current here is the 20 milliampere. And the forward voltage of this LED is around 2 volts. So we already used that according to the formula, and we have the switch here, a push button switch, which is normally open switch. This one is the symbol. When you push it, turns back. That is the switch. So what is new here? Nothing new here. It seems I already have this kind of circuit. I built this circuit. Already built this kind of circuit. This one in my old notebook. This is a transistor logic gate. It's a buffer. I already built this kind of circuit using 22A but different voltage supply. I already built that one. I have already that kind of circuit. But the problem here is this. This one and this one is the same. My problem with this is leakage current again. Here, leakage current also. Maybe the problem here. Leakage current or burst voltage or the switch floating or transistor floating. So I think we need a resistor again here. The same as the previous circuit I built, but different diode placement here, the collector side. So we have now circuit here. Push the button on, just like a transistor buffer gate. Again, with this 1940s technology, very long time ago technology. See, let's build the circuit with the pull down resistor here. We need the pull down resistor here so that the transistor knows what its state. Could be 0 when there's no input here, or pushing the button here. When you push the button, input here is 1. So you need to have the pull down resistor here. And this one, I believe, according to the YouTubers, it's a current sourcing transistor. See this one? Okay, let's build the circuit. Thank you.